In a previous video, we checked out the Ender 3S1, and I liked that printer so much that when I heard Creality was working on the Ender 5S1, I was really eager to get my hands on one, and that's because I do have a preference for these cube frame style printers. Pergear reached out to me and asked me if I'd be interested in testing one, so I definitely said yes. They sent me this printer, and that's the only compensation that I received from them for doing this video. So I would highly encourage you guys to go check out Pergear. I'll put a link to their Amazon web store in the video description down below. This video would not be possible without them. They do things like 3D printers as well as photography, videography, and other tech equipment. So I think it's a lot of things that you guys would be interested in. As well, don't forget anything else you see in this video, things like upgrades, downloadable resources, 3D printable files, all of that stuff. I'll put links to that in the video description down below. So definitely go check that out when you get the chance. Otherwise, let's get started with the rest of this video. We're going to start off here with the unboxing, and Creality has been doing this for a while, so not surprisingly, things look very well packaged. In typical 3D printer packaging form, everything is put in the box in several layers. It looks like the top layer has the Z-axis motion system, as well as a box with smaller accessories, and the middle layer has the sample roll of PLA, as well as the heated bed and the XY motion system, and the bottom layer has the machine base. And the machine base is what we are going to start our assembly with. But before I start putting anything together, the first thing I like to do is I like to pop open the bottom cover so I can take a look at the wiring. I always do a quick inspection to make sure that none of the wires are loose from the factory or have come loose during shipping. Also, I like to familiarize myself with what components are used, and so right off the bat I can see a Creality branded power supply. The screen is pretty obvious up there at the top. And over here on the side, we have the main control board. Overall, things are looking pretty simple under the hood. And one of the things I like to see here is that they're using ferrule terminations on the end of the power wires. All that seems to check out, so we're gonna head back up to the top of the machine, and I've got the 4 main extrusions unpackaged and ready to be mounted to the base. They're all clearly labeled. Number 1s go at the front, number 2 goes to the back right, and number 3 with the yellow sticker goes in the back left. These extrusions are going to be attached to the base with M5x25 socket-head cap screws, but take a look at the front extrusion and there's a small cover in the extrusion slot that you may need to move out of the way so you can get the bolts through the bottom. As I mentioned, these screws are M5x25, and just make sure you're using the ones with the built-in spring washers. Now you can tilt the machine base on its side, and I find this is the easiest way to do this. You're going to get that first extrusion in on the bottom, so you'll see that number 1 sticker on there, and you can start threading in your M5x25 socket-head cap screws. And then you can do the same thing for the other extrusion up at the top there. So you'll see both at the front are labeled number 1. At the back bottom right is number 2. And at the back bottom left is extrusion number 3 with that yellow sticker. At this point, I wouldn't completely tighten those fasteners down just yet. I would get them snug. And the reason for that is that we may need to push and pull these extrusions a little bit to get this frame squared once we get this top portion of the frame in place. The top part of the frame with the XY gantry comes shipped to you in one single piece, and it just rests on top of those extrusions. And again, we're going to be using the M5x25 screws with the built-in spring washers to attach that to those pillars. You're going to be using 8 more of these, and again, I would advise that you do not tighten any single one of them down completely before getting all of those screws in place. Then you can go around the machine, and if you have some sort of square available to you, you can check the squareness of each of those joints before fully tightening those bolts down. I do this every time I build a printer, and the frame is the foundation of your machine, and you want it to be square. Now we can have a look at the Z motion system, and it also comes mostly pre-assembled here with the exception of the print bed, which you're going to have to attach to the Z carriage. You can use the foam that came in your package to support the print bed, and by hand you can turn the lead screw to bring the Z carriage down, and we're going to be using more of these M5x25 socket head cap screws with the spring washers. You're going to need 4 of them. They're going to drop into those extrusions, and then they're going to thread directly into the Z carriage. The heads of the screws will sit in these counter bores, and at the bottom of your assembly, that's where the stepper motor should be, so just make sure you have everything the correct way, and then you can flip that entire assembly upside down, and you can just push the print bed downwards, and now we're going to be attaching these print bed supports. And these come in a few pieces, and they're going to get clamped together with the M5x25 socket head cap screws, these ones without spring washers. And just take note that the smaller piece has a small recess in it, and the instruction manual tells you to put that facing down. So these parts will get clamped around the linear bearing, and the front end of the part will get attached to the print bed support with an M5x20 socket head cap screw. And at the back, again, these are going to get clamped with M5x25 socket head cap screws. So these are different lengths. All of these have no spring washers. The process will get repeated for the other side, and it's just simply a mirror image of the first side that we did. And taking a close look at these parts, you can clearly see that they are labeled with an R for right side and an L for left side. Now we can insert this subassembly into the frame, and according to the instruction manual, we have to do this sort of dance of inserting the bottom of the assembly, tilting the frame up, and then the goal here is to get the top of the Z-axis assembly between the rear top extrusion and this rod here that controls the Y-axis motion system. Once it's in the correct position, we can take these M5x30 socket head cap screws, and these have spring washers on them, and we can put them through the back extrusions, and those are going to thread into the Z-axis assembly that we just put together, and that's going to hold that securely in place. Now we can tackle these plastic gusset reinforcements, and they're going to go in the back bottom corners of the frame. They do have markings on them for right and left hand side, so pay attention to that. And we're going to be using some M5x20 socket head cap screws to secure those in place, and these screws do not have built-in spring washers. Get both screws started before tightening them down, and then switch over to the left hand side of the machine and do the left hand side gusset. The process will be the same, using two more of the M5x20 socket head cap screws, and again, these do not have built-in spring washers. Now we can install the spool holder, and this is a pretty simple little assembly that just consists of one of these sheet metal brackets along with two of these plastic pieces, and the plastic tube gets inserted into the hole on the sheet metal bracket, and the plastic nut goes on the back side, and you can see the orientation of those two with respect to one another, and that whole assembly is going to get attached to the frame using these M5x14 button head cap screws. Next, we can take care of the wiring, and this is a pretty straightforward job on this machine. At the back, you'll find two of these smaller wiring harnesses. These are going to get routed to the top back left-hand corner of this machine, and the other two will have little yellow labels on them with the letter Y. One of them will go to the Y limit switch, and the other one will go to the Y motor. These both have a different number of pins on them, so you can't mess up which one goes where. Then at the back, you'll find two more larger and longer wiring harnesses. And I'll start with the smaller of the two, and I'm going to stuff that into this wire guide bracket at the top left rear corner of the frame, and then I'll move on to the larger one next. And all of those should fit into that little wire guide bracket, but it might be a little bit of a tight fit. And similar to what we just did with the Y-axis connections, you'll find little labels with the letter X on them, and these are for the X-axis connections. One will go to the X-axis limit switch, and the other one will go to the X motor. Then we can take the largest wiring harness, and that one is going to go to the extruder. Taking a closer look at the extruder, it has a little bit of a different connector on it, and it's got these two locking tabs that are going to hold it in place, as well as a nice strain relief bracket. With that complete, we can now connect the heated bed to the base of the printer, and this is done with one of these circular connectors. It's keyed, so again, you cannot mess up the orientation of it, and it's got a locking ring, so you're going to thread that on and just make sure that it's snug. Then at the bottom center, you'll find two more connectors, both labeled Z. One will go to the Z-axis limit switch, and the other will go to the Z motor. And again, despite these connectors having the same label, they do have a different number of pins, so you cannot put them in the wrong place. While we're down here at the back, we should take a look at the voltage selection for the power supply. Make sure that it is set to the correct voltage for your country. Now we can tidy up the wiring, and Creality gives you these nice little clips that you can route your wiring harnesses through, and the clips attached to the 2040 extrusions. I'm going to put 2 on the back of the printer to hold the larger wiring bundle, and then I'm just going to use 1 for the heated bed wire. And now looking at the printer from the left hand side, you'll notice some of these little clips on the top of the frame, and these are intended for zip ties. We can take our small wiring harness going to the gantry, and we can start to use the included tie wraps to secure this in place, and this is just going to prevent this wire from ever catching on anything while the printer is whipping that print head around. Since we're on this left hand side of the machine, this is also a good time to insert the filament guide tube, and one end is going to go into the filament runout detection sensor and the other one's going to go to the print head. Don't forget to install the little blue retaining clip on the filament runout detection sensor end. To keep the extruder harness from flopping around and getting caught on anything, we can use these little tie wraps that are also included in the kit, and those will just get wrapped around the filament guide tube and the harness, and I'm just going to use one of them here to prop up that wiring harness. We're almost ready to get going, but I would recommend to check your V-wheels. Mine came from the factory a little too tight, and when they're too tight, you'll notice that the movement feels a little bit notchy. It's almost like there's flat spots or indents in either the wheels or the extrusion. And so on the print head, you can take a look underneath, and the 2 V-wheels underneath will have the eccentric nuts that you can adjust the tightness of. The same adjustments can be made to the entire gantry, which rides on more of these V-wheels. And again, the 2 V-wheels at the bottom are the ones that can be adjusted. What you're shooting for here is a nice smooth motion. It shouldn't feel like there's any flat spots, and it should definitely not be loose to the point where the V-wheels are just spinning. You don't want any play in these wheels, but you don't want them too tight either. Now that we have the assembly done, we can get into the setup. So plug your machine in, turn it on, and you should see and hear your auto bed leveling probe cycle once, and you'll also be greeted with the Creality splash screen on that front touchscreen. We're going to start by going into settings and then leveling method, because we're going to take care of the bed leveling. On the right hand side, you're going to see a little home icon, and you're going to hit that, and this is going to home the Z axis. The print bed will make its way to the top and eventually park itself somewhere close to the nozzle. In your box, you should have got this nice little material guide from Creality. I'm going to be using this as our piece of paper to get the Z axis offset dialed in. Right now my nozzle is too far away from my print bed, so I'm going to repeatedly press this up arrow, and that's located just on top of the home icon that we pressed earlier, and this is going to bring the print bed up towards the nozzle. While I'm smashing that up arrow, I'm going to be constantly checking the distance between the nozzle and the print bed, and when I feel a light to medium drag between the two, I can move on to the next step, and I'm going to press that number 5 button, and that's going to move the print head to the back left hand corner of the print bed. This is where I'm going to no longer be using that button on the touchscreen to adjust the offset, but instead I'm going to be using these bed leveling knobs at the 4 corners of the print bed. Turning the knobs clockwise will draw the corner of the print bed down away from the nozzle, and counterclockwise will raise the corner towards the nozzle, essentially closing that gap between the print bed and the nozzle. The goal here is to work our way around all 4 corners of the print bed, getting that same distance between the nozzle and the print bed. And again, we're using this piece of paper method to do this, so you want that light to medium drag between the piece of paper and the nozzle and print bed. This is going to ensure that we get a uniform gap across the entire print bed, and you want to only make small adjustments at a time. Don't be afraid to go around 3, 4, even 5 times before everything feels uniform at all 4 points, and then back to the center at point number 1. Once you're happy with your manual adjustments, you're going to go into prepare, then the temperature settings, and you're going to set the heated bed temperature to 60 degrees. And you're going to see that the set temperature is now 60 degrees and the heated bed should start to warm up. Let the bed heat soak for a minute or 2 before going back into the leveling method, and then you're going to hit that auto leveling button. And you only have one option here, and that's just to start the auto bed leveling. The printer will take over at this point and use the auto bed leveling probe to probe a whole bunch of points on the print bed. Eventually, when you go to print something, the printer firmware will now have an idea of the profile of that print bed and be able to compensate for any variations in that print surface. And on the topic of printing, we cannot print without filament, so we need to go into the prepare section. We need to hit the in-out button. We're going to set the nozzle temperature to 210 degrees because we're going to load up some generic PLA. Now when you put the spool on the spool holder, you can see that it is a pretty sloppy fit. Now I haven't made any modifications to the Ender 5 S1 just yet, but you can see this little clip from another video that I have, and I'll put a link to that in the top right hand corner of the screen, that I have designed an upgrade to the generic Creality spool holders. Now this is something that I will eventually do to the Ender 5 S1, and if you guys are interested in doing this to your machine or any of your Creality printers, check the video description down below. I'll put links down there to the printables page where you can download these files, or alternatively you can go to my website, and if you guys cannot print TPU, because some of these parts are printed in TPU, you can buy these from me and support my channel on my website, embracemaking.com. Now you can see the spool sits on the spool holder and the filament gets inserted into the filament runout detection sensor and gets pushed through the filament guide tube. And with the hot end up to temperature, you should be able to push down on the lever on the extruder and then feed the filament down through the hot end, and you'll see it start oozing out of the nozzle at the bottom. You've now successfully primed the nozzle, and you can load in an SD card with a file that is ready to print. And if you guys are totally new to 3D printing, slicing files is a little bit outside of the scope of this video, but if you check the video description down below, I will provide a link to a slicer profile for the Ender 5 S1 for Prusa Slicer. Now at the time of the making of this video, this was something that I couldn't find myself online unless I paid for somebody else's Patreon, which would have granted me access to a file like that. This is something I've developed on my own, and this profile I will make available to you guys for free. Just follow the link in the video description if you want to use Prusa Slicer with the Ender 5 S1. Once you've sliced a file, getting your first print running is pretty easy. You're going to head into the print section, select the file you want to print, and then hit that play button in the bottom right hand corner of the screen. The printer will completely take over at this point, and you should not have to intervene at all. And it's been my experience so far with the Ender 5 S1 that the prints start on their own reliably. Now this is the very first print on the printer. I have not edited out or tried any other prints ahead of this one. And so the only thing I've had to do with this printer is head down into this screen here, tap on these settings over on the side, and this is going to allow you to make a live adjustment to the Z offset as the printer is working. I'm going to press this button at the bottom here that says Z axis compensation, and this is going to allow me to move the bed closer or further away from the nozzle in different increments as the print is printing. And since this is a really small part, it was very difficult for me to gauge whether or not I had the nozzle set up too close or too far away from the bed. It didn't look like it was too far away because I was getting good first layer adhesion, but it may have been just a touch too close, and I'll be able to make those changes in the next print when I go to print something a little bit bigger. But for now, this calibration cube came out perfect. Now there is one thing I noticed that wasn't so perfect, and that is how well this print did stick to this PC coated flex plate. On a small part like this, I was able to release it, but as we'll see on larger parts, this does become a problem. In terms of print quality, the cube came out looking pretty good. There is a tiny amount of ringing around the lettering, but I was going pretty fast on this print. And obviously you guys want to see more than just a calibration cube, so let's take a look at this next print. I wanted to print something that took up a larger portion of the print bed because I wanted to test out the auto bed leveling function and to see how well this thing compensated for any variations in the print bed. It turns out the Ender 5 S1 does a very nice job of laying down a nice uniform first layer using the auto bed leveling matrix. Now I did notice on this larger part that I did have the nozzle set up a little bit too close to the print bed, and I was getting my first layer a little too squished. So that's when I went back into that live adjustment setting that I showed you a few minutes ago, And I moved the print bed down just a touch so that on the next print I wouldn't get such a squished first layer. And now with this larger part, you can really see me struggling to remove it from the flex plate even after letting it cool down to room temperature. Once I did get it off, you can take a closer look at the part and see that I did need to dial in my material settings a little bit more. This is just some pretty standard eSun PLA Plus, and it looks like I was printing a little too hot. You'll notice some really fine wisps of plastic or stringing, and on the top surface you'll notice a little bit of pillowing, so I could stand to decrease the print temperature slightly, which I'll do in the next print. And so we're going to move on to the next part, which is a different part but similar in size. And you can actually see in this clip here that the PC coating started to peel off of this flex plate already because I had to really aggressively pull that last part off. In the last part, I had also mentioned that I made the live adjustment to the Z offset, and so in this part, that first layer came out perfect, and the rest of the part went down really smooth. After lowering the print temperature, I also saw less stringing and less wisps on this part. There still was a little bit, and you can definitely see that in there, but it was greatly improved over the last part that I printed. What wasn't improved was that stubborn flex plate, and I actually destroyed it trying to get that last part off. And luckily, there is a solution in the form of a PEI coated flex plate. And so I reprinted this part with a PEI coated flex plate, and you can pick up one of these specifically for the Ender 5 S1 on my web store, embracemaking.com, and you can see how easily this part removed. Once you let the flex plate cool down, it just pops right off without any effort. And so I went back to the first part to reprint it again, just to reiterate how much easier it is to remove these parts from a PEI coated flex plate than from the original PC coated flex plate. So you can see that it just peels off real smooth. And I wanted to show you guys with the lower print temperature, there is no more pillowing on that top layer. There are still too many fine wisps of filament here, and it's not thick enough that I would actually call it stringing because it's super easy to clean up even just with a heat gun, but it is kind of annoying, and I'm not sure if I'm gonna have to increase the retraction settings a little bit to compensate for that. This is still eSun PLA Plus, but it's in a different color. Next, I wanted to print something with a larger overhang because I wanted to test out the part cooling. Now the Ender 5 S1 has a unique part cooling fan setup, different from the other Sprite extruders that Creality offers. It uses what I believe is a 50 series radial part cooling fan, which is quite a bit bigger than the 40 series fan that you'll see on most of the other Sprite extruders, like on the Ender 3 S1. It had zero issue taking care of this 45-degree overhang, which came out extremely clean, so let's throw something a little more challenging at it. And now I'm printing in eSun eSilk, and I've got this much more interesting and much more challenging Iron Man model. Be sure to check the video description because I am going to put links down there to the materials that I'm using, as well as these models that were not my own creations, so I can give credit to the creators who came up with these awesome 3D models. This Iron Man model was advertised as being able to be printed without supports, and so I wanted to see if the Ender 5 S1 could do it, if other printers were apparently doing it as well. Now, the part turned out exceptionally clean in my opinion. I see, again, a little bit of wisping, but there's not a whole lot, and I'm taking a look at the severe overhangs like under his torso and under his leg, and they came out really nice considering how severe those overhangs are. All of the fine details on his body also came out really nice, and this is a really shiny filament, so it does bring out a lot of the imperfections. On the very top layer right now, I'm pointing to a little bit of pillowing, so perhaps I could dial in my settings for this filament a little bit more, but this is the first time that I'm printing with the eSun eSilk on the Ender 5 S1. I would love to hear what you guys think about these prints, so be sure to put your comments in the comment section down below. To change things up a little bit, I switched over to these more functional parts, and these are fume extractor nozzles that I've made for a laser cutting machine, and I'm printing these in Filaments Depot HT PLA. This material is printed at 230 degrees, which is a little hotter than the typical PLA. Overall, the part came out looking really nice. although there is still that very fine wisping, which I cannot seem to escape so far on this printer. I have easily been cleaning it up with a heat gun, but we'll take a look at another type of filament here. This one is again from Filaments Depot. It's their standard PLA in this really nice indigo purple, and we'll see if I get that same stringing problem on this part here. Already you can see a little bit more of that fine stringing around the horns of this dragon looking thing, and I wouldn't consider this a huge problem because it is easy to clean up with a short blast of the heat gun. But on this print here, I did try and increase the retraction settings from 0.8mm to 1mm, and it didn't really seem to get rid of that problem. Otherwise, again, this is a very nice looking part. All of the very fine details came in looking really great, as well as those steep and sharp overhangs. The part cooling fan dealt with those beautifully. Now this part had some reasonably fine details and they did all come out great, but I wanted to challenge this printer even more with a part with even smaller and finer details. And so I went with this mermaid model. For this part, I switched back to the eSun PLA Plus in this really nice magenta looking color. I thought it suited the mermaid really well, and the print went off without a hitch. Taking a closer look at this part, I want to draw your attention to the very small and fine details around the model's face, ears, hands, and fingers. This part was printed at a pretty tall layer height considering what I wanted to achieve. I didn't want it to take too long, so I did print it at 0.24mm layer height. The printer can go much lower than that, and even still, all of these details came out looking great. As with all of the other parts, there is a tiny little bit of cleanup involved, and this again was with the larger retraction setting of 1mm, and there was a marginal difference there with the stringing. You can really see it across the head and the hand, but more importantly, the very fine details like those pointy ears came out looking flawless. Now to change things up, I wanted to switch materials and wanted to try printing in PETG because I've traditionally had a lot more trouble with PETG than PLA. PLA is very easy to deal with. PETG has a tendency to stick to the nozzle and create a bit of a mess, leading to some failed prints. I started by printing a temperature tower to determine the best temperature to print this Filaments Depot PETG, and then I moved on to printing these parts for that filament spool holder that I mentioned to you guys earlier. I did experience a lot of buildup on the nozzle, and I had to constantly pick that away with a pair of tweezers while the print was going on, but the end result was these very nice looking parts, at least on the exterior. You can see on this bolt here, it looks absolutely beautiful, and again, even with the PETG, very minimal stringing. This is one of the bushings that goes inside of the TPU part to hold the spools. The outside looks pretty clean, but on the inside, it's a mess. I did override the retraction settings for this material in the slicer, and I increased it significantly, but it definitely looks like my PETG profile is going to need some more work for the Ender 5S1, and this will definitely come in time. Based on how nice those exterior faces came out, I'm confident that I can get the interior surfaces to be just as clean, but it's going to take some time. And beyond testing PETG, the other purpose of this print was to test the dimensional accuracy of the printer by printing these functional threads, and it definitely passed the test. So now that I've been using this printer for quite some time, and I really have been using it very extensively, I gotta ask myself, does the Ender 5S1 live up to the hype and advertising promises of Creality? And the answer, I think, is mostly yes. So Creality does have a habit sometimes of promising some outlandish things, and they'll tell you that printers such as the Ender 7 or the Ender 5S1 are high-speed printers, and they're going to print at 250 millimeters per second. And that's kind of true in some circumstances. That's if the print is big enough that the printer can accelerate the print head to get up to that speed. So you're not going to be consistently printing at 250 millimeters per second, but this printer does seem to print ever so slightly faster than what else is out there in terms of the base Creality printers. So I would say there is a little bit of a speed gain here, and if you had the right print, it could print up to 250 millimeters per second, but just set your expectations to be realistic when it comes to the Ender 5S1. I think the big thing here is that it is a huge leap ahead of what the original Ender 5 was, and I do have an Ender 5 here for you guys to check out, the original one. and we can do a little comparison between the two. So we'll take a look at these two and their features, and I'm going to show you guys how much further ahead the S1 is over the original Ender 5. On the original Ender 5, the user interface was the old school LCD screen with the rotary knob, and it was attached to the side of the machine, which was bulky and took up extra space. On the new Ender 5 S1, we've got a touchscreen that's integrated into the base of the machine and doesn't stick out any further. At the top of the printer, the original Ender 5 has the typical Creality hot end and originally came equipped with a Bowden tube extruder. This example here does have an aftermarket direct drive extruder installed on it. The new Ender 5 S1 has a derivative of the Creality Sprite print head. Now this thing is a direct drive extruder with a much higher flow capacity hot end than the original equipment from the old Ender 5. At the back, you'll find a much bigger part cooling fan with those dual part cooling fan ducts, and hidden behind there, you'll find the auto bed leveling sensor, which of course the old Ender 5 does not have. The arrangement of the V-wheels carrying the gantry has also changed. So on the old Ender 5, the V-wheels were on the sides of the extrusion at the sides of the machine, and on the new Ender 5 S1, the V-wheels have been relocated to the top of the extrusion, which seems to make a lot more sense considering how the weight of that gantry is being carried. Another important difference between the two machines is that on the old Ender 5, the linear rods that carried the print bed were 10 millimeters in diameter. Now this would be okay if it wasn't for the fact that the print bed is cantilevered off of these two rods. It looks like Creality finally realized this and upgraded those rods to 12 millimeter diameter rods, which look a lot more stout, even though that's only a 2 millimeter increase on the diameter, but also their mounting points are a lot beefier as well. The print bed support on the original Ender 5 used to be a pretty flimsy piece of sheet metal, and on this example that I have here, it was upgraded to an extremely large and rigid 3D printed piece. Now, Creality did something similar on the new Ender 5 S1 with its new print bed support. These parts here are very rigid, injection molded reinforcements, and it's nice to see that Creality finally addressed this problem and we don't have to resort to upgrading this part of the machine anymore. Another big improvement comes in the area of wire management. The original Ender 5 and a lot of the older Creality machines were just a mess in this department. In the past, I would say this was Creality's weakest points on their machine, and it was just straight up awful. So it's nice to see that they have apparently learned from their past mistakes, and they've placed a little more focus on wire management on the Ender 5 S1, as well as some of their other newer printers, at least from what I've seen. Even little parts that allow you to zip tie wires to the frame, or things like small strain reliefs, really go a long way in cleaning up the wiring, making it safer, and improving the overall look of the entire printer. So now that we've seen that the new model is such a huge improvement over the outgoing Ender 5, I do want to talk a little bit about the flaws of this machine because there are some minor ones. And the first one is what I brought up earlier in the video, and I probably sounded like a broken record, but it's that very fine stringing that I've experienced on a lot of the prints. Now the good news is that it's very easy to clean up. You just take a heat gun and all of those fine wisps just get blasted away with the heat gun. So post-print cleanup is very easy, but I did try tuning it out so they wouldn't be there in the first place, and I had a really hard time doing that. So that is something that I would like to see improved. I'm not sure if it's a flaw of the machine or maybe it's my print profiles. I'm not really certain who to blame there, but I do not have this problem on any other printers. So it is something that maybe is inherent to this machine. Now the second thing was the PC coated flex plate. That thing the prints stick so well to, which sounds good in theory, but when it's time to remove your prints, it's an absolute nightmare. So you're not going to experience the problem where you get a failed print, where the print head knocks prints off of the print bed. But what's going to happen is when you go to remove those prints, you're going to be tempted to stick a sharp object between the flex plate and the print. And this could be dangerous because if it does slip, like a knife or even a scraper, you could hit your hand and you could cut yourself pretty bad. it sticks that well. And you guys saw that I actually damaged the flex plate after the second print. And so you're gonna end up having to replace that. And that means on a printer that you've already spent a pretty considerable amount of money on, right out of the box, you're gonna have to do at least one upgrade, and that is a PEI flex plate. And the last thing that I think could have been improved on this printer, which I feel is a bit of a missed opportunity for Creality, is the overall print volume. It's more or less the same as the old Ender 5, which sounds fine, but it's also more or less the same as, let's say, an Ender 3, which already exists in the Creality lineup. I would have personally increased the print bed size even just slightly from what it is now to about 280 by 280. I think Creality is probably not going to pursue a newer Ender 7, and that was the print size of the Ender 7, 280 by 280, and I think they could have easily fit that within this frame, and that would have differentiated this printer from, let's say, an Ender 3 S1, and would have been more incentive for somebody to pay extra for something like this over the Ender 3 S1. And I'll finish up by telling you guys what I absolutely love about this machine, and that is the repeatability and reliability of this printer. You guys saw me do the setup at the beginning of this video, and I have since not had to touch anything once. I haven't had to re-level the bed. I haven't even had to rerun the auto bed leveling. Every time I fire up this printer, I just select my file and I press print and I walk away. I never have to intervene, and I never have to come back and check on it, worried that the print is gonna fail. And so after this machine gained my trust, which didn't take very long, I immediately started using it as one of my production machines. And I threw a lot of prints at this thing and put a lot of miles on it up until the making of this video, and I never had a single problem in terms of print jams or anything of that nature. It was just turn it on and press print over and over and over. And as soon as I'm done this video, it's going right back on the shelf and it's gonna see more action. And so this means for about 95% of the users out there, you're not gonna outgrow this machine quickly. For general 3D printing, it's fantastic. You're not even gonna have to think about upgrades other than that PEI flex plate, which is nice. And it's a nice change of pace for a Creality machine, because historically that hasn't been the case. You'd get your Creality machine, you'd be very excited, but very quickly you'd have to go down the rabbit hole of spending more money on upgrades. And this thing is the total opposite from my experience so far. And so lastly, who would I recommend this printer for? And I would say a wide range of users. And that's because on the beginner end of the spectrum, you can just take this thing out of the box, get started with it, and you're not gonna get easily frustrated or discouraged, and you're gonna start your 3D printing journey off on the right foot. At the other end of the spectrum, for a more advanced user, it's really the same thing. You're gonna take this thing out of the box and you're gonna start using it. You can add it to your print farm, or you can use it as a production machine for your small business, and you're not gonna get frustrated and you're not gonna waste time taking this printer apart or upgrading it. Now, if you're the type of person who does want to upgrade a machine, this may not be for you. If you do have the budget and you do have the money to burn, you probably could find things to do to this, but in my opinion, you'd be wasting your money because there's not really a whole lot that you need to do to this machine. And so I really think it covers a wide range of users. And for me, it's perfect because I needed a machine that I just didn't want sitting on a table in 1,000 parts. I'm really over that. I still like upgrading certain machines. I do find it to be fun, but this thing is more of a tool for me. And so I use it like a tool, and it's been extremely reliable, and I've been very happy with it. And so again, if you guys are looking to pick up an Ender 5 S1, please visit this video's sponsor, and that's PerGear. I'll put a link down in the video description below where you can find this machine on their Amazon web store. And I would highly encourage you guys to support them. And if you guys are looking to support me, check out my website, embracemaking.com. I offer all sorts of 3D printer upgrades and related maker gear and equipment. And you're also gonna find the printer profile on there for Prusa Slicer. So go check out embracemaking.com. Thank you guys so much for watching, and I'll see you guys in the next video.